So having gone through this situation, this is what we would expect to see with a horizontal surface. Now, if we move to the vertical, here's what's different. We have a big old box again. And now we're going to have an angle to contend with. So what changes when we look at this horizontal versus on an incline? Well, there are a couple of things that change. So gravity is no longer perpendicular to the surface. Gravity is going to be straight downward. And I want to take the time to really emphasize this, that it makes an angle. So this is the force due to gravity. Gravity doesn't change just because we tilted a board, but the way in which gravity relates to the forces that are exerted on the object is going to change because now it makes an angle. We still have the normal force, of course. And we may or may not have friction, but I'm just going to write that in anyway, just to kind of build off of what we talked about. Force of friction. But since this relationship between friction and the normal force is true, then I can still write this is equal to the coefficient of friction times the normal force, because that's always true. Okay, now I may or may not have a force pulling down this way. I may or may not have a force pulling up this way. And honestly, I don't really know if friction is going to be up the incline, but I do know that friction always opposes the motion. So if this thing was moving up the ramp, friction would be down. If it's moving down the ramp, friction would be up. And if it's just sitting there because there's enough friction to keep it from sliding, then friction would be up as well. So now let's take the time to break gravity into its X and Y components. So, well, you might say, doesn't it only have a Y component and no X? True. But it's probably more productive to think about this constraint. So this constraint says there's no acceleration along the vertical axis. Over here, the constraint has changed. And so the constraint is no acceleration perpendicular to the incline. No acceleration perpendicular to the incline. Yeah, so that's big. And if that's the case, then we might want to think about not trying to resolve these two into their X and Y components, because that would be unnecessarily messy. Let's instead think about coordinate axes that are either perpendicular to the surface or parallel to the surface. So now we can resolve the weight into components that are either perpendicular or parallel to the incline. So I'm going to extend this as a right triangle where these two perpendicular vectors add together to give me this hypotenuse. Right, again, so our constraint is since there's no acceleration perpendicular to the incline, then let's just think about gravity. What's parallel to the incline? What's perpendicular? Because this part is perpendicular. And this part is parallel. So now it's the parallel component that could help move it down the incline. But what does the perpendicular component do? Well, in the absence of any other forces that are perpendicular, it tells us what the normal force is. So now instead of the normal force being equal to all the weight, it's going to equal a fraction of the weight. And we can figure out how much as well. Now, by taking a look at the diagram, it doesn't take too many steps in this proof in order to show that this angle is the same as this angle. We could prove it geometrically, but also we could just take a look at extremes, because if this was level, the angle would be 0 and this angle would be 0. And if this angle was 90, this angle would be 90. So that statement holds up under that scrutiny. So for gravity, we have two components to keep track of. We have the perpendicular component, and we have the parallel component. Now, if this is the angle we're talking about, then the perpendicular component is adjacent. And here, the parallel component is opposite. So this is going to equal mg, and since it's opposite, sine theta. And then this is going to be mg cosine theta. So what are we going to use these two components for? Well, again, because the constraint is that there's no acceleration perpendicular to the incline, then what our perpendicular component does is it tells us about the normal force. And this tries to make it slide. I'm going to stop.